All right, some more questions from Chapter 11. This time, Exercise 11A, Question 16. Again, reviewing our unit on Unit 3. 16. F is equal to e to the 2x plus 1. The tangent to the graph at f at the point where x equals b passes through the origin. Find b. Okay, so we've got to find the point where the tangent passes through the origin. Well, tangent, we're already thinking gradient, aren't we? So let's go ahead and find the gradient. F dash of x is going to be the derivative of e to the something is e to the same thing multiplied by the derivative of the power, which is 2. Okay, and now we know that f dash of b, well, it doesn't really tell me anything about that except that it will pass through the origin. So, therefore, the gradient of the tangent is always going to be 2e, and we're at point b, so 2b plus 1. It's a number. It's no longer an exponential equation because it's just got a value in there for b. So we should be able to work with this. And we've got the equation of a tangent, so the equation of the tangent is going to be in the form y equals mx plus c. But what do we know? Well, we know where m is equal to 2e to the 2b plus 1 and c equals 0. So now I know the equation of the tangent is y equals 2e to the 2b plus 1 multiplied by x. Still pretty confusing, this one. But we've just stayed calm. We've said, well, I found the tangent. I can put it in where the tangent is. I know the y-intercept. Let's put that in. Let's fill it in. Now, we still want to find b, but we know a point on the line, don't we? We've used the fact that when x is 0, y is 0. But can we actually find a value for b? Let's just pause while that bell rings right after that rude interruption. So, yeah, we've used the 0, 0 point, but what's the other point we know? Well, we know back in the original equation, this was at the point when x equals b, so the y-coordinate at that point would be e to the 2b plus 1. So I can substitute in that point. Sub in e to the 2b plus 1, or that's the y-coordinate, b, comma, e to the 2b plus 1, and solve for b. Because I'll only have one variable then, so I should be okay. Let's see how we go. So e to the 2b plus 1 equals 2 e to the 2b plus 1 multiplied by b. And look at that, we've got a common factor there that we're going to be able to cancel. 1 equals 2 times b, 1/2 equals b. Now I did it a slightly different way from what you will see in the work solutions. I hope this way makes a bit more sense because this is how we'd go about usually finding equations of tangents and that sort of thing. What they've done is they've used the gradient rule, y2 take y1 over x2 take x1, and they've used the 2 points, this point here and the origin, to find it. Again, works perfectly well. They've said that is then equal to the derivative, which is, of course, the gradient. I think this way is a little bit clearer, but it's up to you. Hopefully that made some sense. Let's go back and have a go at part B, though, because we're not done yet. So, f of x equals e to the 2x plus 1 plus k. So this is just a vertical translation that's happened somewhere. The tangent... Oh, another bell. They've also had the blowers out today. You'd love it. So all we have to do from here is go through the same procedure again, and hopefully we'll have the same amount of luck. Somehow my pen disappeared. Let's try that again. All right, so f dash of x. Well, it's still going to be the same derivative, isn't it? Because the derivative of a constant doesn't change. So I've got 2e to the 2x plus 1. For some reason, I've got that looks like a k. Let's make that the right letter. That will make it a little bit easier for everyone. So I've got my derivative there. The tangent to the graph at the point where x equals b passes through the point 0, 0. So again, I'm going to have So the equation of the tangent is going to be y equals 2e to the 2b plus 1. So this is the tangent when x is equal to b. And the y-intercept will be 0. So that's going to be the equation of the tangent at x equals b. Maybe I should make that a little bit clearer. So what I've done is I've substituted in b. We've got what we had. Same as the working that we did just before. Now we need to find k in terms of b. So what else do I know? Well, I know the other point on the line. So we've got this thing here. Oh, I didn't have my x there. Y equals mx. Chewy, come on. All right, so we know the other point on the line. We know that the other point apart from the origin is b. And when I substitute b into the original equation, I'm going to get e to the 2b plus 1 plus k. That's the only difference this time. It's got this plus k on the end. Well, let's substitute that in and rearrange it so we get k in terms of b. So here I've got, therefore, e to the 2b plus 1 plus k. That's my y value. And that's going to equal 2e to the 2b plus 1 multiplied by my x value, which is b. Well, to get k on its own, I've just got to subtract that other value. So this is 2e to the 2b plus 1 multiplied by b minus e to the 2b plus 1. That looks a little bit ugly. Why don't we factorize out that e to the 2b plus 1? And I'm left with 2b minus 1 there. That looks a little bit nicer. That's all there is to it. Look, not particularly nice questions, these two. It's good you asked about them because they're a little bit messy, a little bit algebra heavy. That would be at the harder end of what I'd be expecting, but certainly doable for you guys. I hope that helps. Good luck. Keep up the great work. Keep the questions coming, and we'll catch you in the next video.